So accordingly, so this is the ARP header which you have seen in the Wireshark tool. So we have hardware address type, we have protocol address type, we have hardware address length, protocol address length, and the kind of operation, whether it is a request or reply, and accordingly the source hardware address will be followed. So generally the specific length of this particular thing will be the 32-bit registry generally. So as hardware address or the MAC address is 48-bit, so we are combining those 32-bit plus 16-bit, that will be 48-bit. And whereas the protocol address is only the 32-bit, it will be continued. Source protocol address and the source protocol. So 16 plus 16, 32-bit. Okay. So accordingly, the parameters will be there. So the same example, what are the things we have discussed here? So we can observe that this entire range or the highlighted things belongs to the ARP header. So according to the protocol, if it is IP, it is 000. If it is reply or request, then it will be accordingly depicted in the opcode parameter, right? So this will be the ARP request and reply. So whenever a client is trying to send communication, try to find out where exactly the destination is located, we'll be sending an ARP request where we can observe the MAC address is not noted actually, so it is 0000, and we are getting the ARP reply from the destination, so the opcode will be 0002 filled by the MAC address, right? So you can observe the Wireshark is trying to give the vendor name also, as in the 48-bit MAC address, the first 24 bits belongs to the vendor or the company who developed the physical card, and followed by the next 24 bits which is unique to that. So the combination will be unique for every device or the physical or the NIC card. But we can observe that Wireshark already have the database of this kind of vendor addresses. So this particular 001438, so it understood that this belongs to Hewlett Packard company, and we can observe that 001676. Now this particular 24-bit belongs to Intel. So based on the database which is already there in the Wireshark, it is also trying to give us what is the vendor name accordingly. So it will try to resolve that using the first 24 bits and try to make the observation that what is the vendor of that particular NIC card also. So these are the commands which you have seen, the ARP-A. -A is nothing but we can observe all the ARP kind of devices that are available on the operating system. And the next thing is, let's say there may be some cases where we need to manually update the MAC address to IP address mapping. So in that case, we can use the command ARP space -s. -s is for static. So we need to mention the IP addresses to which the hardware address has to be mapped. So in this case, we can see the example. So a MAC address is mapped to a IP address, and that is made as static. So these are the static address we can make. The other important concept is called the gracious ARP. This will be mostly used with respect to the kind of behavior whenever the system starts or whenever the network starts. If there is some already IP address associated with the network card, the network interface will try to send a gracious ARP onto the network. Now let's say many of us maybe observed a particular kind of thing called IP conflict. I think most of us have observed this IP conflict behavior in the LAN environment. How the operating system will come to know that there is already an IP address conflict means it is understanding that there is already an IP address which is already there on the network. The similar IP addresses my system is also using. So how the system will come to know that there is the IP conflict because of this gracious ARPs. So that means whenever a request or reply that is normally not needed actually according to the but this will be made by the system. In this case, what happens is you can observe both the source and sender IP address and the target IP address will be the same as the source. Okay, so it is not a different kind of IP address. source as well as destination is same, but the sender MAC address, it is actually mentioned, and the target MAC address is nothing. That means it is a broadcast. It is sent to all the systems on the network saying that I already own this particular kind of IP, right? So this is what the main intention of the Gracious ARP. Okay, where it is mostly helpful to actually detect the IP conflict. So whenever a machine receives the ARP request containing a source IP that matches its own, so then it understands that, okay, there is already a system that is already available on that. So it will give us a prompt that there is an IP conflict on the particular IP. So this is how the Gracious ARP will be used as a thing. So this is one of the example of that, but accordingly the ARP will be used with respect to the vulnerabilities in the ARP, because as we have seen the dynamic behavior of the ARP, so we can observe why actually this packet analysis and these protocols are also very important, and this day one is important because also we are understanding the kind of feature or the kind of behavior the protocol is actually using. Now in this we can observe from this entire ARP behavior that there is no authentication that is required to actually update the table of the ARP. Okay, because simply we are typing, because whatever that ARP table which we have seen, there is no manual intervention of us mostly. It is all the addresses which are actually captured in the ARP table of dynamic behavior. That means whatever that is traffic that is coming on the wire, the system is able to understand, okay, these are the corresponding MAC address with respect to this corresponding IP address, and the mapping has been dynamically done by the system itself. So there is no manual intervention or there is no authentication saying that this particular IP has to be mapped with this particular MAC address. So this is one of the security labs in the ARP, using which many of the spoofing techniques or in the kind of man-in-the-middle attacks are done, which we'll be discussing detail in the tomorrow's session. So this kind of attacks are only possible with respect to the kind of protocol behavior also, because whenever we talk about an attack or any kind of security issue, that is associated with one or the other protocol also, right, or the protocol behavior. So if you're talking about the application attacks, so there may be some issues with the HTTP protocol or how that is dealt, or if there is some kind of attack in the DNS, so there may be some issues with the DNS. So if there is some kind of attacks in the man-in-the-middle or any kind of spoofing techniques, so then there may be a problem with the ARP or this kind of protocol. So it is again associated with the protocol behavior. So if we clearly understand how these actually protocols behave or what is the exact functionality of the protocols, then accordingly the security measures can be taken and we can have a clear understanding of the security devices or the security kind of analysis that can be made in the next level. So to understand these kind of things, the understanding of the protocols is very important. That is where we are mainly focusing on protocols and what is the functionality, what is the kind of behavior the protocol will actually get into. So this is about the first two protocols we have discussed today. The main thing is about the understanding of the TCP/IP protocol suite, and to understand the Ethernet or the medium access control or the logical link control, the Ethernet headers. And the next level protocol we have is for the ARP, or nothing but address resolution protocol, where this is used to resolve the IP address to the MAC address. So basically we are trying to understand how this communication will be actually happening at the layer 2 or at the physical layer. Now we'll try to understand what are the different layer protocols in the next session or in the afternoon session, how these kind of protocols are actually interlinked from one layer to other. Then we'll try to understand the different protocols here. So with this, any more questions on this, so that we can conclude here and we can continue in the afternoon session?